Okay, now we're going to move on to prime factorization. Prime factorization means we're going to list things or break numbers down to find their prime factor. See, the word factor is right in there. So I'm going to quick give you a list of prime numbers. We have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. Those are kind of like the ones I know off the top of my head. You will not need numbers pretty much bigger than 31 very often. So if you could just memorize those, that would be great. I know of 2 ways of doing this, and they kind of have silly, cute names. First is called the Christmas tree method. This is the top of the tree, and we're going to break it apart. So I'm looking for 2 numbers that multiply to 90. Well, 3 times 30. You could do 2 times 45, 9 times 10, whatever. 2 numbers that multiply to 90. 3 is a prime number, so I'm going to circle it. It now becomes an ornament. I'm going to break apart the 30. I need 2 numbers that multiply to 30. Well, I'm going to pick 5 and 6. Again, you could have picked 3 and 10. You could have picked 2 and 15. It doesn't matter. In the end, we'll get the same answer. Now, when I look at this, 5 is a prime number, so I put it in an ornament. 6 is not prime, which means I can break it apart. I need 2 numbers that multiply to 6. So I have 2, which is prime, times 3. Well, now all of my numbers are in an ornament. That means I'm done. These are going to go in numerical order. So I'm going to have 2 times 3 times 3 times 5. When we're doing prime factorization, you will use exponents for the constant, the numbers. That means this is 2 times 3 squared because I have 2 3's times 5. My solution would be 2 times 3 squared times 5. The next way of approaching these problems is to do what's called the birthday cake. This is the bottom tier of the cake. I need a number that goes into 90 that is prime. We can only pull prime numbers out. Well, I can divide by 2 pretty fast. So I'll take 2 out, leaving me 45. Okay. I need to take out another prime number that would be 5, well, leaving me with 9. 45 divided by 5 is 9. I could take out a 3. Oh, I got to take out another 3. So it's kind of like division, but we're building tiers on a birthday cake until you get to the top where you have 1, and that's the candle. So for this one again, I would still have 2 times 3 times 3 times 5. You put those in numerical order. And when I write it for prime factorization, I still would have 2 times 3 squared times 5. Okay, I have to go to the next page. I'm going to give you practice on this one. We're going to do the Christmas tree with the ornaments, and we're going to try the birthday cake. It doesn't matter to me which method you use. They're both great. So I'm going to start with 96. Wow, I don't know a bunch of numbers that go into 96, but again, I am pretty fluent in dividing things in half. So I know that would be 48. Well, it's even, so I'm just going to divide that in half again, which gives me 24. Oh, well, 24 is 4 times 6. Ooh, neither one of those is prime, so I don't put anything in an ornament, but I can break 4 apart to 2 times 2. Okay. But I have 6 hanging out here. I need every number at the end to be in an ornament, and 3 times 2 is 6. So I have 1, 2, 3, 4, 5 2s and 1 3. I will write my final answer as 2 to the 5th because I had 1, 2, 3, 4, 5 times 3. Okay. We're going to move over. Oh, wait. No, we got variables. I know that a squared is a times a. Oh, we just have b to the first, so times b. I have c squared, so that'd be c times c. You will write constants with exponents. You will take variables and space them all out. Let's practice the same one more time using the birthday cake method. It's kind of like just division. I'm going to ignore the variables for a minute. This time I'm going to take out a 3 just to mix it up. 3 goes into 9 3 times. 3 goes into 6 twice. Okay. I need to pull out a prime number, so that's even. I'll take out a 2, leaving me with 16. That's even. Take out a 2, leaves me with 8. 8 is even. Take out a 2, leaves me with 4. 4 is even. Take out a 2, leaves me with a 2. And I need one more 2 so that I can get to the birthday candle on the top. I count. I have 1, 2, 3, 4, 5 2s again. And 1 3. I will write this as 2 to the 5th times 3 because I had 5 of those times A times A times B times C times C. All right. The thing you need to be aware of for this one is the negative. I don't care if you decide to use birthday cakes or Christmas trees. I'm going to use a Christmas tree and I need to pull out the -1. That is mandatory. You may not leave it there. So I would have 45 here. Well, I know 9 times 5 is 45, and that's prime, so I'm going to circle. 9 is 3 times 3. They're both prime. So I have -1 times 3 times 3 times 5, which is -1 times 3 squared times 5. Now I need to address the variable, so I would have times A because it was squared, times B, it is squared, times C times C times C because it is cubed.